Hey, welcome back. Our second lesson in nuclear chemistry today. The other lesson, the previous lesson, we looked at alpha, beta, and gamma particles. Today, 3.2, we look at positrons. Oops, spell it right. I'm still practicing talking and writing at the same time. So positrons and electron capture. So these two particles. Again, we're working with 5 types of decay. We took a look at the first 3 last time, 3.1, with the alpha, beta, and gamma. Now we're looking at positrons and electron capture. Positrons are pretty much exactly like they sound like. Positrons have the charge of a proton and the mass of an electron. And that's what a positron is. I think about that name, posit. So a positive charge from the proton and the mass of an electron. So it's like an electron with a positive charge. So a positron. The name really makes really good sense, I think. I hope you guys agree. The symbol for a positron, we can use that E like we did for an electron. It has 0 mass, again, the mass of an electron. But then the key here is that it has a +1 charge. So watch that +1 charge. It's not a negatively charged electron. It's a positively charged positron. Or, again, if you guys prefer the Greek method, you can call it the beta symbol. So it's a positively charged beta particle, a positron. So we get positrons when you have a proton in the nucleus. And again, the symbol for proton, 11p, or a lot of times you see it 11H because a hydrogen has 1 proton and most of them have a mass of 1. So either of these symbols is fine for the symbol of a proton. And what happens is that proton splits in half. It forms a positron. So there's the +1 charge. And you're doing the math, we've still got the mass, but the bottom number is gone. So 1/0 is a neutron. So it forms these 2 items, a positron and a neutron. And again, that can help our ratio. If you're thinking about the ratios, the proton to neutron ratios in the nucleus, let's say you have 21 protons and 19 neutrons. Well, through a positron emission, release that positron, there it goes. Through a positron emission, you can turn a proton into a neutron. So 21 protons would become 20. You have 1 fewer proton. And 19 neutrons would become 20 because now you have 1 more neutron. Now you have a 20 proton to 20 neutron, a 1-to-1 ratio, much more stable nucleus. And that is positrons. Finally then, the last type of decay, electron capture. So electron capture, this one's kind of weird. Electron capture So this one's kind of weird. It occurs when an electron is pulled out of orbit. So remember, those electrons are kind of orbiting around the nucleus, not like the solar system. We'll talk more about those orbits later. But the electrons surrounding, it's in the space surrounding the nucleus, and it falls out of the orbit and combines with a proton to form a neutron. So it's kind of a weird event. Now it is an electron, so our symbol actually is the exact same symbol we were using for beta. It's an electron. And you are welcome to use the E for electron or the Greek letter B for beta. Either one you're more comfortable with. It's these numbers here that are really most important. So watch those. Now here is kind of the weird part about electron capture. Watch that word capture. It's that electron capture. So here's our generic element X. It has an atomic number of Z and atomic mass of A. Electron capture occurs on the reactant side. So I don't draw an arrow immediately like I have for all of my other types of radiation. I'm drawing a plus sign. Those two are going to combine and you're going to form A, does not change. Z becomes -1. And we have a new element, Y. That's going to be a different atomic number, so you end up with a different element. So watch out for electron capture. This right here is kind of the key. Electron capture, the electron is on the left side of the arrow, on the reactant side of the arrow. When we did beta emission, it was the same particle, but it was on the right side. It was over here as a product. So watch that. That's kind of the deal with electron capture. And it's really kind of the backwards of what we looked at yesterday. So here's our electron. And it's actually going to combine with a proton. So it's really like the opposite of a beta emission. Here's our proton. They're going to combine and they're going to form a neutron. Again, if you do the math here, the -1 on the bottom, the +1 on the bottom, they combine to make a 0. We have 1 on top and 0 on top. You add those up, you get 1. That's our neutron. So this is what's happening in an electron capture. Walk through a couple of examples with you. So our first example, thallium-232. Decays through positron emission. So here's our positron. So it starts off with thallium. Now this one's kind of a tough one. Watch out for thallium. A lot of people confuse thallium with thorium. Don't. This is not thallium. This is thorium. They're different elements. So watch out for that TH. I've been known to actually confuse those myself. Thallium should be TL. So looking for TL. Where is TL? Aha, there it is. Thallium, TL, number 81. So we'll start with thallium, TL is atomic number 81. And again, right here is our mass, 232. It's decaying through positron emission. Again, we got to kind of memorize what a positron is. It's a positively charged electron. And then from there, it's just balancing. So 232 on the left, 0 plus 232 will give us that. 81 on the left, 1 plus 80 will get us up to 81. So then we take a look at the periodic table again. 80, Hg, mercury. And there we go. There's our balanced equation, balanced nuclear equation for thallium-232 decaying through positron emission. Do one more example for you guys. Take a look at how electron capture works. So nickel 59 decays through electron capture. Okay, so nickel 59, I don't know off the top of my head what nickel is, but 59 is a pretty small mass, not a very big mass. So I'm guessing it's going to be towards the top of the periodic table where the smaller elements are. And there we are. There is nickel. He's number 28. So there's my 28. The next part of this can be a little tricky, so slow it down. Slow it down. There's going to be no race on this next test. Here's nickel, 59, decays through electron capture. When we see that capture, we know that it's going to be a plus, not an arrow. So most of the time we just put an arrow. Here we're going to put a plus. There's our beta particle or our electron. It's being captured. These two combine now to form, well, 28 plus -1 is 27. 59 and 0 is still 59. So find element 27. There it is. Cobalt. CO. And there's our first electron capture. All right, guys, you got your 5 types of decay to work with. You should have some good amount of homework. Some of them are pretty challenging problems. I like them. I think they're pretty good. So think through them, see how you do. And we'll be back next week with half-lives. Till then, see ya.